Opened our ArcGIS Pro project, the watershed delineation. So now let's get started. So the only dataset I will be using to get started with this tutorial on watershed delineation, so which could be my DEM, that is my digital elevation model, have downloaded from USGS Earth Explorer. There's RTM DEM of 30-meter resolution. Now let me show you that. So this is our digital elevation model I have downloaded from USGS. So the link will be given in the description to how to download the SRTM DEM from USGS Earth Explorer. So this is a digital elevation model here. So it is in file format, that is in TIFF file format. So now to add our digital elevation model into our ArcGIS Pro, just click this and drag this into our current view of the map. So now we can able to visualize it. So as you can see, it is zoomed into our correct location of this SRTM DEM. So now let me zoom out and show you the exact location of my DEM is located. So it is located in India. So you can able to see that. So basically it is located in South India. So this particular DEM is lying in towards South India. So now suppose if you want to visualize the terrain elevation more clearly, so what you can do is go to this layer and right click and click this option called symbology. So once you did that, the window will be open here, symbology of this TIFF, that is our DEM TIFF. So here you can select a color, the color scheme for your DEM. So from here you can select a bit more variety of color schemes, so which could reflect the terrain elevation. So now let me select this particular color. So here you can able to visualize the highest elevation is represented in blue color and the lowest level of elevation is represented in red. So now let us invert this color. So now you can able to clearly visualize the highs and lows here. The highest elevation is given in this red color and the lowest level of elevation is given in blue color. So you can visually able to identify the hills and valley. So this is the valley and this will be our hills. So the low-lying areas are clearly represented in blue color and the high-lying areas are represented in red color, red and yellow. And here you can able to visualize the drainage patterns here. So now when delineating watersheds, so the very first thing we could like to do is, so that is we could go ahead and fill the sinks in our DEM. So the reason we are doing to fill the sink is to basically to eliminate the small imperfections so that are usually presented in this kind of DEM data. So in order to fill the sinks, so what you can do is you can basically make use of the fill tool that is available in our ArcGIS Pro. And now navigate to this option called analysis and click this option called tools, that is our geoprocessing tools. So click this. So once you did that, the window opens up, that is geoprocessing here. So here you can click this option called toolbox. So in that you have to navigate to our spatial analysis tool. So in that, so in the spatial analysis tool, there is a tool called hydrology. So click this. So in that you can able to see the fill tool here. So now let me click this. So in this tool, basically we're going to input our surface raster, that is our elevation, digital elevation model, our DEM data. So now let me rename this particular DEM data, the name of the DEM data here. So I'm going to replace as DEM data. So now I have replaced our name of our DEM data, that is have represented as a DEM data here. So now let me navigate to our geoprocessing here. So in that we're gonna select our DEM data. So we're gonna select our SRTM DEM data. So click this. Now choose your output surface raster. There is our choose your folder location. So where you could like to save your file. Now let me select. And now I have selected my folder location called shapefiles and click open. And now let me enter the name. So let me enter as fill. So now click save. So once you did that, we're going to click this option called run. So now we can able to visualize here our fill has been completed. So the filter fill layer is available here in the table of content section, and make sure that you give a file extension .dif, that is diff. And now I could like to turn off this dem data here. So the next major step in delineating a watershed. So next we have to create a flow direction raster here. So what we can do is we can basically go back to our geoprocessing tool. So we have to navigate to the option called spatial analysis tool. So in that you can able to see the tool called flow direction here. So click this tool, and now the input surface raster will be our fill. So we have to select our fill, and you can choose your output flow direction raster. So now browse this option to save your output flow direction raster here. So now click save. So make sure that you give a file from file extension of .dif, and now click save. So quite important over here, we have to select our flow direction type. So here 3 different flow direction types available. So starting from D8. So the second flow direction type is MFD, and the third is DINF. So if you're not familiar with the flow direction type, so I could like to suggest this option called information here. So click this option here. So just place your cursor over this information symbol here. So now you can able to visualize the flow direction types. So the details of this flow direction type. So here the D8 assigns the flow direction based on the D8 flow method. This method assigns the flow direction to the steepest downslope neighbor. So this is the default method. So we're gonna stick to this method. So you can also try other methods here. So for this video, we're gonna stick to this particular method called D8. So once you selected your flow direction type, so navigate to this option called run and click run. So now the flow direction raster is available in our table of content here. So the process has completed. So now let me explain about this flow direction. So we have each of the flow directions are represented in different numbers here. So you can able to visualize that. Each of the flow directions are represented in specific color starting from 1. So 1 here represents the flow direction towards east. So now let me show you that. So here you can able to visualize that each of the number here specific shows us a different flow direction. For example, the 1 is the represents the flow direction towards the east, and the 2 represents the flow direction towards southeast, and 128 here represents the flow direction towards the northeast. Likewise, each of the specific number represents a different direction. So in geographic information system, the flow direction is the key component in analysis of surface water flow. So the D8 flow direction method is a commonly used approach model the flow of the water across a raster grid. This method assigns the flow direction to each cell in the grid based on the steepest downhill slope. So the flow direction codes here assigns a unique code to represent each of the 8 possible flow directions. These codes typically uses a compass direction, for example, north, northeast, east, and southeast, south, southwest, west, and northwest. So corresponding to 8 cardinal and the intercardinal directions. So the D8 method is a simplified model that assumes the water flow direction to one of the 8 neighboring cells with the steepest descent. While it may not capture all the gradations of terrain and flow pattern, it is computationally efficient and widely used for many applications including flood modeling and watershed analysis and environmental planning. So now let me get back to our ArcGIS Pro. So based on this direction coding, that is the 1 here represents towards east and the 2 represents towards the direction coding, that is the flow direction is towards the southeast, and the 64 here represents the direction towards north. So now you can able to visualize that based on the color. You can find the direction coding here. So that is our flow direction raster. Next, we could like to create a flow accumulation raster. So we have to navigate to this tool. That is our geoprocessing tool. So in that, so we're gonna select our navigate to spatial analysis tool. So in that, we're gonna select our flow accumulation tool. That is in we're gonna select flow accumulation tool. So click this. So once you did that, the flow accumulation tool is available. So now input your flow direction raster. Now let us select my flow direction raster here. So select it and choose the output file location. And now selected my output file location, that is a flow accumulation. So now click save and make sure that you give the file extension of .tif. So click save. And now the output data type will be in float and the input flow direction type will be in D8. So click this option called run. So now the flow accumulation is completed here. So you can able to visualize here in the table of content section our flow accumulation raster. So now we can able to see we have managed to create a flow accumulation raster. Accumulation raster you can clearly able to visualize here. That is our highest flow accumulation raster is marked in white color and the lowest flow accumulation raster is marked in black color. So that is the grid cell with the highest flow accumulation raster is marked in white color. So you can able to visualize here the white represents the highest flow accumulation grids cells and the black here represents the lowest flow accumulation cells. So that is represented in black color. So now let me explain about how the flow accumulation works. So flow accumulation tool calculates the accumulated flow as accumulated weights of cell flowing into each downslope cell into output raster. If no weight raster is provided, a weight of 1 is applied to each cell and the value of cells in the output raster is the number of cell that flows into each cell. So in the graph below, the top left image shows us a direction of travel from each cell and the top right is the number of cells that flows into each cell. So this is our direction coding. So cell with a high flow accumulation are the areas of concentrated flow and may be used to identify the stream channels. And cells with a flow direction of 0 or the local topographic highs and may be used to identify the ridges. So now I could like to click on a flow accumulation raster, right click and select the option called symbology. So instead of going with the stretch color type, we could like to move on to this option called classify. So click this option. So in the manual classification, so instead of 5 classes, we could like to use the 2 classes here. So we're gonna select 2 here. So now you could select a different color scheme for your flow accumulation raster. So now let me click this particular color here. So now you can clearly able to visualize the flow accumulation here. So here you can able to visualize here the highest flow accumulation raster is marked in this color and the lowest flow accumulation raster is marked in this color, that is in dark blue color. So now I could like to reduce the upper bound value of this particular flow accumulation raster. So by reducing, we can able to visualize more tributaries in this flow accumulation raster here. So now I could like to reduce this value. So now the upper value is around 23,74,635. So I could like to reduce its value now. And now we can able to visualize the new branches has been observed in our flow accumulation raster here. So you can able to visualize the new tributaries. So by reducing values, we can able to visualize a few more tributaries it is observed. So in our flow accumulation raster here. So now let me reduce further our upper value here. We're going to reduce to 500,000. And now we can able to visualize the tributary of this main river. And now let me reduce to upper value up to 250,000. So it is currently in 500,000. So I'm going to reduce to 250,000. Now and now we can able to visualize the tributaries. And now you can clearly able to see the river lines. And now let me reduce the upper value to 100,000. And now we can clearly able to visualize our river lines. So before creating a watersheds, our next step will be, so what we need to do is we basically need to identify the point which you could like to use as the outlet of the watershed. So for example, so if you pick a point over somewhere in this point, so then your watershed will be created by taking into an account of the corresponding drainage area. So from all of this river region, so from this particular entire region, so that is lying above the particular outlet that is lying over here. So suppose you're going to select this as the outlet point. So for example, if you pick the outlet to be in this point of the river lines here, so yeah, all this drainage will be picked as a watershed and ignoring everything else. Similarly, if you're going to pick a watershed outlet here, so it's going to consider all these branches, that is all of this river lines as a watershed, and it's going to ignore everything else. So suppose if you choose your water outlet as a here in this point. And similarly, if you're going to pick the outlet point to be this particular area, so this particular river line, so it's going to take a watershed for this particular area and going to ignore all other river lines. So when trying to delineate a watershed boundary using ArcGIS Pro, so the way to specify the particular outlet point is by creating a dedicated point shapefile. So for that we're going to create a point shapefile. So we're going to navigate to this option called view. So in that, we're going to select this option called catalog pan. So once you did that, so the catalog pan opens here. So here in this, we're going to navigate to the option called folders. So in that, you can visualize a folder called shapefile. So you can also create your own shapefile, or you can add your folder location just by right click. So in that you can create a new shapefile. So to add a folder collection, so you have to navigate to this folder. So in that, right click, and you can add a folder connection. Suppose if you wanna save your shapefile to that particular folder, so you can add a folder connection here. So I have created a folder connection called shapefiles here. So in that, there is our shapefiles and TIFFs will be available. So now we're going to create a shapefile that is a point shapefile. So for that, right click, and we're going to select this option called new. So in that, we're going to select this option called shapefiles. And now let us enter a feature class name, that is our outlet points. So now I have entered the feature class name as an outlet point. So the geometry type is we're going to select as point. And next we have to select our coordinate system. So now let me select the current map. So that is in GCS. So once you've done that, we're going to click this option called run. So now in the table of contents section, you can visualize our point shapefile, that is our outlet points. So now we have created an empty point shapefile here. So now we could like to create an outlet point using our point shapefile. So here you can able to visualize the rivers are moving towards the southwest direction. And now I could like to create my watershed outlet point lying somewhere here. So what I'm going to do is we're going to select our point shapefile here and navigate to this option called edit. So in that, we're going to click this option called create. So in that, we're going to select our outlet points. So we're going to click this option called create a point feature. So once you selected that, it appears in the plus like symbol here. So now all you have to do is zoom into your desired outlet point here. And now I have zoomed into my output point location here. So I'm going to place my point. Now make sure that you place your point on the top of this grid cell. Now place your point on this high flow accumulation cell. So now I have placed a point here. And now a new record has been created in our point shapefile here. So now let me show you that. So now we can able to visualize here. We have created a new point which is indicated in our attribute table here. So now let us finish it off by clicking this option here. Apply the changes. And now navigate to this option called save, which is available in the edit section here. Click this option. So click S to save your edits. So once you did that, I'm going to zoom out here. So now we can able to visualize our outlet point here, so you can clearly able to visualize that. And now to clear the selection, you have to click this option called clear. So deselects it, so you can now able to see the point here. So once you have done that, we have to navigate to this option called analysis. In that, we're going to select tools. So in that, we have selected spatial analysis tool. So in hydrology tool, so in that we're going to select and now we could like to select this tool called watershed here. So it determines the contributing area above the set of cells in raster. So click this tool. So here we have to input our flow direction raster, and now select your input flow direction raster. So we could like to select our input flow direction raster. So this is our input flow direction raster. And now input raster of the feature pour point data. So that is our outlet points. So it is our outlet points. So we're going to select our outlet points here. So once you did that, so in our case, we have only one outlet point here. So it will generate a corresponding watershed. And once you did that, we're going to select the pour point field here. So we're going to leave it to a default that is an ID. So now the output raster, choose the output file location. So let me select it. So enter the name as watershed and click save. And now go to this option called environments. So in that we're going to select our processing extent. So let me select the processing extent to be our DEM data here. So once you're done selecting your processing extent, so click this option, run. And now visualize the watershed has been completed here. So now we can able to visualize it. So we have managed to create our corresponding watershed using our outlet point. So now that takes into account of the drainage area, which drains into this point that is our outlet point. And now let me select this particular layer and go to this option called appearance. So in that, we're gonna move on to this option called transparency. So now I could like to reduce the transparency of this layer. So now we can able to visualize the drainage here inside this watershed. So here, so let me reduce the transparency here. So now I can clearly able to visualize our drainage pattern. So this is our watershed and this is our drainage. So now you can see this, right? So this particular stream here, so this appears to be our main stream here, so which joins to our outlet point. So the all other appears to be the tributaries to this main river here, so it joins to outlet point. It is still in raster file format. So suppose if you want to convert to an S3 shape file format, for that, so it can be done by using raster to polygon tool that is available in our toolbox. So in the conversion tools here, so from this particular tool that is from raster, so we can use this tool called raster to polygon. So in case suppose if you want to create a sub watershed from within this watershed, so in that case, so for creating a watershed we have used an outlet point of this particular area to create an outlet point here. For creating a watershed boundary, we have used this particular outlet points here. And suppose if you want to create a sub watershed, so you can use this point to create a sub watershed. For example, so this entire region is of one watershed boundary. So you want to create a sub watershed, so you have to use that particular outlet point shapefile. So you can place a point shapefile here. So as a result, this will be classified into a separate sub watershed. And likewise, you can place a point here, the outlet point here. So it will be classified as a separate sub watershed boundary. And likewise, you can place a point in this area. Another sub watershed will be created. And now I'm going to show you how to create a sub watershed. So first we have created a watershed boundary. So now we're going to create a sub watershed boundary. So for that, so navigate to this option called view section. So we're going to create a new point shapefile. So go to the navigate section. So navigate to view section here. So in that, we're going to click this option called catalog pan. So here we're going to navigate to this folder called folders. So click this here. So now we can able to visualize here we have a shape files. So in that we have our outlet points. So similarly, I'm going to create a new shape file. So right click and click this option called new and navigate to shape files. So once you did that, the geoprocessing tool will open, create a feature class. So in that, we're going to enter our feature class name. So we're going to enter as outlet point for sub watershed. So short will be I can write it in the outlet sub. And now I have entered the feature class as an outlet sub. So geometry type will be the point, and the coordinate reference system will be the current map. And now click run to create a new point shapefile. So now you can able to visualize here in the table of contents section here the outlet sub. So we're going to use this point shapefile to create a sub watershed. So now we're going to select our outlet sub shapefile. Select this and navigate to edit. We're going to create this option. We're going to click this option called create features. So now we're going to click this option, that is our outlet sub represents. We're going to create our sub watershed boundaries. So click this. So once you did that, we're going to apply this particular option. We're going to click this option, create a point shapefile. So now the plus flag symbol appears again. So now we could like to create a sub watershed for this particular watershed boundary here. So now we're going to place some points here. So we're going to consider this one of the river lines, consider as a sub watershed. Let me turn off other layers. So now let me place my point, outlet point here. So now next we're going to place my outlet point. So we're going to place the outlet point here. So this will be a second sub watershed for this watershed boundary. And similarly, let me place my watershed outlet point here for sub watershed. And now you can able to visualize here. I have placed the outlet point here and this part of the area. So and also here, and also here. So once you finish placing outlet points, so navigate to this option in edit section. We have to click this option called save to save edits. So now click yes to save edits. So you can be able to visualize here. I have placed an outlet point here, and also here I have placed an outlet point here, and this particular sub watershed here also here. Here are another outlet points. So once you're done adding your outlet points, click this option and make sure that you save your edits. So that is available in edit section. You click save. So now we're going to navigate to the analysis section here. So in that we're going to click this option called tools. So now, so go to the spatial analysis tool. So this is our spatial analysis tool. In that we're going to click hydrology. So now click this tool called watershed. So now we're going to input our flow direction raster. So click the flow direction raster. And now we're going to input our 4 points data, that is the outlet sub, that is outlet sub watershed. So we're going to select that outlet sub. And in ID section you have to select your unique field ID. So FID will be our unique field ID here, and choose your output file location. And once you did, click this option called run. So now we can able to visualize we have managed to create our sub watershed. So now to visualize our river lines, select this particular layer and go to this option called appearance. So in that we navigate to transparency. So now let me reduce the transparency here and let me turn this off. And now we can able to visualize our river lines. So we can able to visualize that. So based on our outlet points, it is categorized into different sub watersheds. And now we can able to visualize it now. Let me turn this on, turn this off. And now it is the two files are in raster file format. So we had to convert it to a polygon using a tool called the conversion tool, raster to polygon tool. So suppose if you want to calculate area, so we have to convert it to a polygon and we can calculate area. So now we're going to convert our raster, that is our sub watershed, to raster to a polygon. For that we're going to navigate to analysis section here. So in that, we're going to select our tools. So now we're going to navigate to this tool called conversion tools. So in that, you can able to let me navigate to conversion. So in that, we can you can able to visualize here from raster. So in that, we're going to select this tool called raster to polygon, and our input raster will be our watershed flow. So we're going to insert that watershed flow, and the field will be value and the output polygon feature. So let me save to the output file location, and now have entered a sub watershed. Now click save. So once you did that, we're going to click this option called run, and now you can able to visualize we have converted our raster to a polygon. Now let me turn this off here. You can able to visualize it more clearly. And now we have managed to create a sub watershed. So go to this of a table of contents section. In that, we're going to click the sub watershed, right click, and select this option called attribute table. So now from the table of attribute table, so you can able to visualize we have 9 different sub watershed. So let me select this. So now you can able to visualize that. So here, and now let me close this. And now suppose we want to generate this river lines, so this particular river lines. So for that, so we're gonna use a tool called reclassify tool. So now let me go back and let me enter here. We're gonna search the tool called reclassify, and now we have entered as a reclassify. So here you can able to visualize a tool called reclassify. So now click this tool called reclassify here. So we're gonna click this tool. So once you did that, we're going to input our raster, that is our flow accumulation raster. So input raster will be our flow accumulation raster. So once you did that, we have our the classes here, that is from 0 to 100,000. So it will be going to enter as a 0 here. The new class will be from 0 to 100,000 will be named as 0, and 100,000 to this particular number will be named as class 2. So once you did that, we can click this run. And now you can able to visualize our result here. So it is reclass flow 2. And now to generate our river lines from this particular raster, we have to move on to the tool called conversion tools. From conversion, we have to click this tool called raster to polyline. So now we're going to select our input raster. So the input raster will be reclass flow 2. So I'm going to click this reclass flow 2. So field value we're going to select yes. Let me check here. Right click and click the attribute table. So now we can able to visualize here. We have to select the value field. So the 0 represents this particular value, and the 2 here represents and this polyline, that is a river line values here. So now let me close this. So you're going to select the field value, and now click run. So it is converting to raster to polyline. So the results is now available here. So let me turn this off here. So now you can able to visualize our river lines, and let me turn on our sub watershed. So we have finally managed to create our river lines with our sub watershed boundaries. Let me turn on this sub watershed boundary here. So you can also perform a clip operation to remove this the polylines outside this sub watersheds boundary. So for that, we're gonna navigate to this. We're gonna search by clip. So now we're gonna click this. So now click this tool called clip for analysis tool. So in that, we're gonna input our riverline riverline shapefile. So that is this particular shapefile, raster t reclass. Gonna click this, and the clip feature will be our sub watershed. So once you do that, you can click this option called run. And now the clip is completed here. So let me turn this off here. So now you can able to clearly visualize our subwatershed and our watershed boundary and our river delineation for the specific study region. So in this video I have shown you how to perform a watershed delineation using ArcGIS Pro. So thanks for watching and please subscribe to our channel and give us a like.